Welcome to The Explainer. Today, we're zooming out, way out, to look at human history through a totally different lens. We usually think of history as this long, dramatic list of kings, empires, and wars. But sitting right beneath all of that, actually driving every single major shift in human civilization, is something much more fundamental. We're going to explore the core thesis that human history is actually a succession of energy regimes. Basically, the way we capture, store, and use energy dictates exactly how our societies are structured. Okay, let's dive into this because this quote perfectly sets the stage for our entire journey today. Energy is not an end, it is an amplifier. It's just a neutral multiplier of human power. Whatever it is we want to do, whether that's building sprawling cities, setting up global supply chains, or on the flip side, destroying entire ecosystems, energy simply amplifies our capacity to do it. The more energy we have, the faster and bigger we can build or destroy. Before we trace this history, we just need to make sure we're on the exact same page about what we're actually measuring. We're talking about primary energy. This is the raw energy naturally available out there in the world before we humans transform it into something else, like electricity. So we're talking about solar radiation, biomass like wood, the wind, flowing water, and geological stocks like coal, oil, natural gas, and uranium. The fundamental rule of history is this: whoever controls these primary energy sources controls the organization, the economy, and the military power of society. So here is our roadmap for today. 1. The solar indirect era. 2. The coal rupture. 3. The mobility revolution. 4. The power of the atom. And 5. The renewable return. All right, kicking things off with part 1, the solar indirect era, biomass and muscle. For the vast majority of human existence, everything we achieved was strictly boxed in by the natural rhythms of the sun. Going back millennia, our very first primary energy source was just wood and biomass. Then, as we built the great empires of antiquity, think Mesopotamia, Egypt, Rome, China, the main engine of civilization was muscle, human and animal muscle, fueled by agriculture, which, if you think about it, is essentially just indirect solar energy captured by plants. Eventually, moving into the pre-industrial era, we figured out how to harness wind and water using basic mills, but we were still entirely dependent on whatever nature happened to provide on any given day. The defining characteristic of this whole era was its strict physical limits. If you wanted to heat a home, forge metals, or build a fleet of ships, you needed wood, which meant you needed forests. Agricultural growth was completely at the mercy of solar cycles and seasons, and power was hyper-localized. Because civilizational growth was capped by the physical limits of these distributed energy flows, human progress was just slow and steady. I mean, think about it. You literally couldn't pack up a waterfall and take it with you. To break out of this, humanity needed a radically different source of power. Which brings us to part 2, the coal rupture, the first major break. And this brilliantly illustrates what happens when we move into the 18th and 19th centuries. We see this dramatic, almost violent break from the natural cycles that had governed humanity forever. For the very first time, we had access to a highly dense energy source that couldn't care less about the weather or the seasons. Coal offered continuous, concentrated production. This one physical property birthed the steam engine, which then led to railways, which then allowed us to mine even more coal. The macro sociological outcomes were absolutely staggering. It triggered mass production, birthed the industrial working class, sparked rapid urbanization, caused a massive population explosion, and drove the expansion of colonial empires desperate for more raw materials.
Moving right along to part 3, the mobility revolution, oil and globalized gas.
So coal was incredibly powerful, but man, was it heavy and bulky. As we moved into the 20th century, humanity discovered a brand new multiplier: liquid energy. And the timeline here moves insanely fast. It kicks off in 1859 with the first commercial oil well in Pennsylvania. By the early 20th century, the internal combustion engine is everywhere. And by the mid-20th century, oil is powering global aviation and massive maritime logistics. Oil totally transformed not just how things were made, but how quickly and how far they could actually be moved. Let's put these two side by side for a second. Coal gave us immense power, sure, but it was essentially stationary power. It fueled massive factories and heavy railway networks. Oil, on the other hand, is a highly dense liquid. It is infinitely easier to transport, store, and pump. This specifically enabled individual mobility through the automobile and created a deeply interconnected, globalized economy through shipping and aviation. Natural gas eventually emerged alongside it, acting as a flexible, slightly cleaner complement to coal for heating and electricity. But make no mistake, oil was the true architect of the modern globalized world. Part 4. The power of the atom, fission. As energy demands went completely through the roof in the mid-20th century, scientists unlocked a hyper-concentrated realm of power hidden right inside the nucleus of the atom. Nuclear fission, which is the splitting of heavy atoms like uranium, offered something totally unprecedented. It gave us an astronomically high energy density and continuous, stable power production with very low direct CO2 emissions. But as the source text neutrally points out, it also introduced unprecedented civilizational risks. We're talking about long-lasting radioactive waste and the potential for severe, catastrophic accidents. Because the stakes are just so incredibly high, fission requires an immense level of social acceptability and flawless long-term institutional management to work.
Finally, Part 5, the renewable return, modern natural flows. Now, what's really interesting about this slide is how it frames the late 20th and 21st centuries. We are currently undergoing what the author calls the renewable return, and it represents a fundamental paradigm shift. Look, for the last 200 years, our entire civilization has been built on a concentrated model, digging up centralized, extractable stocks of fossil fuels and uranium. The renewable return is a massive shift back to a distributed model. It relies on the decentralized, smart capture of natural flows that are happening all around us anyway, like the sun and the wind.
The specific technologies driving this new era are solar photovoltaics, massive modern wind turbines, advanced hydro, and geothermal energy. But here's the catch. Simply generating this power isn't nearly enough. Because the sun doesn't always shine and the wind doesn't always blow, this era requires massive electrification, huge advances in battery storage, and highly intelligent smart grids. Consequently, the geopolitical currency of the whole world is shifting. Power is moving away from the nations that just extract oil reserves and heading straight toward the nations that control critical metals, supply chains, and tech innovation. When we step back and look at all this, we can see it building into a universal pattern. The author outlines a very precise four-step mechanism for how these energy transitions happen. First, you have a technological innovation. Second, this leads to an increase in energy density or efficiency. Third, this new abundance of power triggers a deep social transformation. And fourth, it results in a massive redistribution of global power. But here is a vital, totally counterintuitive takeaway from the source material. Historically, new energy sources do not immediately erase the old ones. They stack on top of each other. We actually use more oil, coal, and renewables today than ever before. The transition is additive, which just compounds our overall impact on the planet. So, the absolutely crucial point is this. We cannot look at the energy transition purely as a technological puzzle to be solved. The source material brings up a really important ethical consideration here, warning against the illusion of clean energy. Remember that quote from the very beginning? Energy is an amplifier. If we use abundant, clean solar power to fuel endless resource extraction, hyperconsumption, and the destruction of ecosystems, that energy isn't morally neutral. It simply becomes electrified destruction. Without an ethical framework guiding us, even the greenest technology can actually accelerate ecological collapse. It's a sobering thought for sure, but one we definitely have to discuss. Energy is the engine of history, sure. But humans, we're the ones holding the steering wheel. The transition we are living through right now isn't just about swapping out old coal plants for shiny new solar panels. It's actually a profound test of our maturity as a species. Our energy choices today are literally going to dictate the moral and physical survival of our future. So as we master these new, incredible flows of power, the ultimate question we really have to answer is this: what kind of civilization do we actually want to power?